So, in fact, I can probably actually describe the pseudocode if you want for it, because it's like 3 lines.
Okay.
So, at standard IO, right, and then at main function with, well, all that there is car start input with fgetS, with first argument being input, second argument being input.
Mm-hmm.
And then third one being standard in. Now, then I put a print out statement to, spit out the string.
Oh, my gosh.
Okay.
But there's a seg fault when fgetS is run through.
Mm-hmm.
And in Gdb, it's
I just don't know how I feel about that.
or after it gets
I think they look funky on this side. I love parentheses about that. I think that if
So let's see if we can find that through GDB. It's I don't know if we can get it far enough to see what's going on, but I think we can.
Oh my god. Like handwriting?
No, it's good.
Like here? Like that? Wait, I want to see that.
Exactly that.
He's talking about
Exactly that.
after my condition. Show me space like that. I don't know if I could. Oh, if you do like the
No, it's also
when you
do like your else, you put like the code base there.
All right, so
And he's only after it gets there.
What?
let's start. We are about to call fgets entry 120 standard in. And if I do this, right, it will let me put something in and it will seg fault. Okay. About the only thing I could suggest is if you're calling a function and that function is seg faulting, once it seg faults, it's too late to figure out what's going on. And if it's a function you wrote, you can say step and start working through that function. But we didn't write fgets, and if we step into it, it's a nightmare. So here's my suggestion. Before you call the function, take a really close look at what you're passing it. Okay, so I can print standard in. I think it'll let me print, right? And that's a 1, it's a file star, that's good. Okay, 120 is just an integer. But print entry, that's a 0. So I'm trying to store what the person types starting at memory location 0. That's the seg fault.
Where to store? You have to malloc it.
You have to malloc it or do something. So one thing you can do is, just declare it to be an array of 120 characters.
Yeah, and then I think that will take your...
Yeah, and that's what that 120 in the middle of the fgets call means. It says I'm guaranteeing I've got space for 120 characters. So that will definitely work.
Interesting. So, for my K1, I had exact setup, but it still worked. Is there a reason for that?
It can work sometimes. You might get lucky and it might be pointing somewhere that's available.
Okay. So
Right?
got pretty lucky then.
Right, so this one entry is pointing to Genu.
Well, as long as it consistently works in K1.
Mm-hmm.
So, like, it doesn't seg fault ever in K1.
And you may be, you may be using, if this is happening inside a function, for example, it's really happening on the stack. And it may be that you did something earlier that set things up so that this variable happens to be pointing to a good location.
So if I want to keep the car star entry, then I have to malloc it?
Yeah, so in that case, you need to malloc it. So valgrind can help sometimes, right? So I ran valgrind on car, I said hello, and then it gave me this message up here, use of uninitialized value of size 8. And it said line 6 of car.c. And then it tells me down here, address 0 is not stacked, malloced, or recently freed.
I see.
Right, and that gives you a little more information. And it tells me I'm aborting with signal 11. So yeah, if you don't want to declare it statically, right, I can malloc it like that. I forgot standard lib. Yeah. All right, so entry starts off at 0, you call malloc, and now it's a nice location.
Do you always get 120 just because, what is there?
That's my age. Oh, it's showing my age, that's not my age. So when I was learning programming, most things were 80 characters, because punch cards were 80 characters, 80 columns, right? And so that's why terminals until recently were always 80 characters across. But when you were printing out, if you had the wide fan fold paper, it would print 120 characters. And that was like, you know, the high-end premium stuff. So I just got in the habit of making everything 120. That's part of my signature, right? Part of my fingerprint. Is that a vanilla ho-ho?
It's a zebra cake.
Oh, it's a rolled up zebra cake. Whoa. That's awesome. Okay. I love zebra cake because they're like slightly salty.
Whoa.
Yeah.
I didn't recognize that until you said it.
Yeah, that's their magic. All right, so other questions on PA1, PA2? Yeah.
So when we're passing in a list, like say into our search function,
Mm-hmm.
can we safely presume that that first thing being passed into that first pointing for a sentinel?
As long as you're a good programmer and you're playing by the rules,
Okay.
right? So you're the one who's calling this thing.
Right.
So as long as you make sure that that's the case, yeah, that's a good assumption. And the idea of a sentinel node is that theoretically every list has, you know, a node in the beginning that might just point to null, but we know that the list itself is never going to be null itself. So it's always safe to take the thing that you're passed and look at the dot next field, for example, or the arrow next field, right? If we don't have a sentinel, we can't assume that. But as long as you're the one writing the code that's calling it, you can ensure that that's the case, and then it's a safe assumption.
Okay.
Yeah.
This isn't a question about PA1 or PA2, but so like normal functions can have a return value, and we
Mhm.
use that in like our main function or whatever.
Yeah.
What would be the purpose of having a return value for your main?
Oh,
And like how would you get to that?
so there's a main function that returns 10. That's the return status of the command, which was the program that you just ran. So from bash, $? always gives you the return status of a command. So if you try to search for something with grep and it doesn't find what you're looking for, $? is 1. So you can tap into that to know if you found something, or if you do Zenity, you can see if the dialog timed out by seeing if $? is a 5. Well, any program that you write in C, the way you return from the main program, if you return an integer, that's the value that you'll get for $. So it lets you pass back information to the caller. And it's not a big integer. Right, so we can pass back a 32-bit character. And we only get the last 8 bits, the last byte.
Is there a reason why you chose that as the...
Because I wanted a big hex number that wouldn't have a bunch of
Were those
zeros.
random letters?
The shed beef.
Yeah, no, I saw that.
Yeah. But that's a valid hex number.
Okay.
So you'll see that in lots of code. You'll see it in memory because it's really easy to pick up on, right? Our brain recognizes words that are actual words. So if you're doing something like, you know, looking at a hex dump, dead beef will jump right out at your brain. So like if you have a sentinel node, you can put hex dead beef in there, and then when you're looking at your memory dump to see what happened, you can find your sentinel really easily. So there's a few words like that. Someone has a tattoo of that somewhere, I don't know where. They should. What?
What's our text though?
Oh, so, yeah, so, if I try to cat a file that's not meant to be human readable, I get all this weird stuff in there. And sometimes it messes up your terminal and makes it go funny colors or things like that. If you do it on putty, it says putty, 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 putty. So there's different ways that we can look at the contents of a file. Octal dump is one of them. So if you say octal dump in the name of a file, it shows you the contents in octal. And it's nice and cleanly printable, and if a pattern is repeated, it just shows you a star. So this first column is the location in the file, and then this is, in this case, 8 words of information. But XXD is another one that shows you addresses and hex on the left, and then shows you the content broken up into 16-bit chunks, and then over here on the right it shows you the human readable version of that. If there's an ASCII code that it can print, it will print it, otherwise it'll just print out a dot. So it doesn't mess up your screen, but you can see where there's basically strings stored, and it's a useful way to interact with and debug and analyze files that are binary. So if you're trying to write something that creates a WAV file, right? WAV files have a bunch of binary information, flags and other information like that. You can look at the WAV file like this pretty easily.
So if you did XXD on a .c file, that's where you would see the actual strings that
Mhm.
you type?
So if I XXD car.c,
Okay.
right, there's the ASCII codes and there's the readable version. And you can dash B to see it in binary,
Whoa.
if you're into binary, and so on. So when you get into bit flipping, and there's a chapter in my book on bit flipping. Bit flipping is, I can get this out of your way. Bit flipping is, taking strings of bits and doing things to put them together. It's what we do in 270 when you want to add two numbers together, and the first number is these 2 bits, and the second number is the 2 bits next to them in port A. If you've done 270, you know what I mean. And so you have to strip these off and shift them over and mask them and add them together and get your sum, and then shift that over into the rightmost 3 bits. That's bit flipping, right? If you're trying to do that with files, these kinds of utilities are really useful, because you can go in and you can actually see exactly what's going on, and that can help with debugging. And it's good when you're in a crowded cafe to just throw that on your screen, and people will oh, she must be hacking something. Yeah.
So I think I remember this being a thing that was mentioned a while ago, but the actual text files themselves are organized in a certain way, right? Like the first few lines will tell you what type of file it is and whatnot, and then the rest if you theoretically knew the way that it was ordered for a specific file type, then you could tell what everything else is.
Yeah.
Is there any particular way that you can figure out what those standardizations are for certain file types? Like a JPEG, for instance?
You can probably Google it. There's probably tables out there that'll show you this.
Okay.
For a particular one, right, you can look up JPEG format and see that, or for a WAV file, you can see that. But there's probably a table. I would Google something like file type headers or file type signatures or fingerprints. And someone's probably compiled it. And the operating system does that, right?
Yeah.
If you have a WAV file and you try to display it with a image viewer, it'll usually tell you this isn't a recognized file type.
And so, a JPEG is going to have the same header and everything, depending on whatever machine it's on, right? Okay.
Theoretically.
Okay.
Except if it's one of those things that has multiple standards.
Yeah. I listened to a podcast a while ago that talked about the faking of information, and how, because because it's becoming so easy to like take videos and voice and stuff.
Yeah.
That they're gonna need a lot of like software engineers to work in the media
Mm-hmm.
and create code that analyzes things and make sure that
Yeah,
it's
yeah.
not fake.
That's an interesting science right now.
Yeah, so I thought that might be cool as like analyzing a JPEG to see if it's been edited.
Yeah. Good SLP.
Yeah, I wish I thought of it.
Yeah.
before I committed to it.
Cool. Good stuff. All right. Other questions? This section wavers in and out of sync with the earlier section, because the earlier section sometimes only has like 5 people in it. And I don't think there's enough groupthink there for people to want to come out and ask questions. So it's usually a fairly quiet class, and we just kind of jump into whatever the topic is. So this is good. So there was a question about commenting code. And different ways to comment code, and we were talking about this a little in the beginning of class. And I should have a copy of my textbook, but I have no idea where it is. Yeah, I'm not going to look for it now. I don't know if I have anything in here that's helpful, but let's see. I don't have hyperlinks. I don't know. I'll just make some general comments. Basically, the goal in commenting is you know, tell the reader why you're doing whatever's going on in your program. Okay, don't tell them you're setting I equal to I plus j. Tell them why you're setting I equal to I plus j. So keep track of the length of the output string would be a good comment if I'm adding a string of length k to my output string, which previously had length j, right? I equals I plus j. Yeah, so keep track of the length of the output string. Outer loop iteration, a bubble start, right? Stuff like that. As far as how you comment, if I'm doing a bunch of things in my program, if I'm doing like 5 lines of C for one purpose, right, and I believe that the reader can understand how these 5 lines of C go together, I'll probably put a comment in the beginning. And I'll probably throw a line of white space before, and then just put in a comment or 2 comments or a bunch of comments saying what's going on in this next 5 lines of code, right? Why am I doing whatever's happening down here? And then I might not comment those lines themselves. If I'm doing something like, you know, I equals I plus j, which is really just one operation, but there's a reason for it, right? Throw a comment on that line, just put a slash at the end, and you know, describe why it is that you're doing this. If I'm getting into a section of my code that's doing something major, chances are it should be in a separate function anyway. And functions, ideally, you're documenting, you know, in the beginning of the function, what the function does, what you pass to it, what it brings back, what the side effects are, what the possible errors are, all of that sort of information. And you can do ASCII art, right? So this was actually from a student last year in some linked list code, and they drew a nice picture here of how they were you know, inserting something into the linked list. And, you know, everything is equally spaced, usually in these editors. So you can do ASCII art, and that helps a lot. And I think she did it for her own bookkeeping while she was developing the code. But it also makes it really easy when somebody's reading it to see what exactly is going on. A arrow next equals B arrow next. That's a pretty simple statement, but there's a lot going on there, right? So picture can say a lot, possibly more than words. Now, this is when I went a little crazy on a project with my ASCII art, because I had a linked list of linked lists, and the linked list nodes themselves had multiple pieces to them, and I didn't want to try to keep track of it, so I drew this picture in the beginning. And that's all just a comment, right? Compiler doesn't care what you put in there. But I went back to this so many times, I printed it out and had it on the side of my desk, and was constantly referring to this while I was working on this project. And then coding style, right? It's like I say, develop a style that works for you. If statements, right? Do you put the curly bracket opening the if block on the same line as the if, or do you put it on the line below the if, such as this? Or do you put all of your stuff in line if it's short enough to fit? Some people like that, some people squirm when they see that. Do you indent the last curly bracket, or do you move the last curly bracket underneath the if? Do you indent the first curly bracket, or leave the first bracket up here, or maybe put the first bracket underneath the if? Do you put a space after the curly bracket and start on a new line? There's all these different ways you can do this, right? But if you do it the same way every time, it's a whole lot easier for you to read it. It might be harder for somebody else, but don't worry about that. You're the one who wants to read your code when you're developing it. You don't want to have to think about it. So if I always write my if statements like this, which I don't, but if I did, and you know, one day I started writing them like this, it's harder for me to go through my code. It's not a big deal, but it's a distraction. And you want to be able to focus, all right? You want like all your energy and attention to be on trying to find a bug, trying to code up this algorithm, whatever it is you're trying to do, not, you know, where does my if statement begin, that kind of thing. Stuff like this, right? C really doesn't care about spaces. It's not like Bash. So you can space this a bunch of different ways, and I've seen all of these in code that I've looked at or used, and none of them are more or less right than any other. It's just style, right? Personal choice. But me, if I see this, that's very natural to me. If I see this, my brain kind of gets jarred. It has to think about it and translate that into an if statement. And that's a distraction, right? So I'm very consistent in how I write it. If it's a variable, I usually do variable equals constant instead of constant equals variable. But if this x is some complex expression like a call to f gets, I actually do it like this. Right? That's just me. I've been coding a long time. You develop more and more quirks and habits over time. And like I say, this is part of why it's easy to look at code and sort of tell who wrote it. And same thing with functions, right? Where you put the brackets, where you decide to indent, and so on. And for loops. Yeah, I think that's all I had to say about that. Does that help at all? Like I say, you can't really go wrong with more comments. I'll regret saying that someday, then I'll tell you to stop putting in novels. You know, I always had song lyrics in my code when I was an undergrad, because I was always listening to music, and I was usually pumped up and I get something, it would suddenly be working, you know, and it would be like a really great piece of the song, and I would just like put the current lyric in there. And then, you know, when I go back through the code and I get to that and I get to the Pink Floyd lyric, it's right, I remember exactly what was going on right there. I remember what it was I did that got this code to finally work right at that moment. Those are all good, you know, tools that will help you when you're going back to your code and expanding it or changing it or something like that. It's your code, right? It's your creation, and have fun with it as much as you can.
I've heard of different, like, jobs having different requirements for style of code. Like,
Oh yeah, yeah. Yes, that's another reason to have fun with it, because I've had students who have written to me, you know, a few years after my course and said, I miss your class because we could just write code, and I really miss those days. And yeah, it depends where you are. Let me see.
Have you had many experiences with something like that?
I've been really lucky. I've tended to work in places that was not filled with a lot of programmers, and so I was kind of like the wizard that they tried not to mess with too much, because he might, you know, leave or break something. So usually, I was given a lot of free rein, but there have been cases. Largely, what happens is I'll get involved with a startup, and it's that kind of environment where, you know, we need somebody to do such and such, and you're available, so do this. So you get to do everything, you know. But then it grows and it gets bigger and it gets bigger, and as it gets bigger, it gets more and more kind of bureaucratic, and then they start coming in, you know, with you can only use variables that start with the letters A through E. It's like,
really?
why? Well, that's the decision from the technology board. Well, who's the technology board? Well, it's someone who was on an airplane flight and read something in a Sky Mall magazine that talked about something, and they said, okay, you can only use 5 letters for variables, we'll have fewer bugs that way. So, and now, you know, so that's usually when I think about moving on. And that's another nice thing about being in this field, right? There's usually a lot of opportunity. So you work your butt off and do a really good job, and you know, build your network and do right by whoever's paying you. And after a few years, you can start, you know, branching out and calling more and more of the shots. And that's nice, because this goes into so many different areas. It's a good setup. All right, Gdb Quiz. So first of all, I hope everybody did Quiz 2. It's due tomorrow, I think. If you haven't, take a look at it on Canvas. But it's basic C variable declaration kind of stuff. Things that you probably could have done before we even started this quarter. So take a look at that. But I want to talk about the Gdb Quiz. So this isn't due until the 5th. But it's got some interesting things. So there's a program on the server under /temp called G1, and it's compiled with GDB support. So you can run this by saying GDB /temp G1 and start. But there's no source code available, so you can't just eyeball it. But you can step through it. So, so this is an exercise set for getting more familiar with GDB. So question 1, set a watch point on I. So there's a variable in here called I. I can print its value. Well, it's uninitialized, so it's just 2 to the 15th minus 1. And if I start stepping through, you know, it'll change value at some point to a 0. And there's another variable in here, x, which is equal to 5. And as I run the program, x will change value. And the question here is, at the point where I changes to 5, what's the value of x? And so we could step each instruction and check the value of I, but we can set up what's called a watch point. So we can say watch the variable I, and now if I just say continue running, it'll continue running until a variable I'm watching changes value. And it'll say, oh, the old value of I was 1, the new value of the old value was 0, the new value is 1. And now I can print the value of x, and I see that it's equal to 81. And I can say continue, and I just changed to 2. And I can print x, and it's equal to 418. So we can use watch points to say, run as many steps as you want until this variable changes. Increases, decreases, changes to 0, any change in the variable. Okay, so question 1, do what we just did, but go until I changes to 5 and then see what the value of x is. That's your answer for question 1.
Can you set up multiple watch points?
Yes, you can. Yeah, you can watch a bunch of different variables.
I think in watch I, can you just do continue?
Yeah, I did continue to say keep running. I could have said next a bunch of times, but I don't know how many times I'd have to do it. And if you set a breakpoint, you can say continue, and if you get to the line that you set a breakpoint on, same thing, it'll come back to GDB.
One more time, what is the difference between step and next?
So next, if my next instruction is a function call and I say next, it will execute the entire function and then come back to GDB.
Okay.
If I say step, it will go into the function and come back to GDB before it starts executing. So if you want to debug a function that you're about to call, say step,
Okay.
and it'll take you into the top of the function, and now you can go through that line by line. If you say next, it runs the whole function, comes back, and then it says, okay, I'm back.
So with step, that's how you can check like variables between like the actual function.
Mm-hmm, exactly.
Step next.
Yep. So if you did 270, this is the difference between step over and step into. Next is like step over, and step is step into. It's in the debugger.
So let's say that you have like a linked list variable in your main,
Mm-hmm.
right? And then you call a function and send a pointer to that.
Mm-hmm.
If you go through like the function that you send,
Mm-hmm.
and you're watching that variable,
Mm-hmm.
like let's say that you next it,
Okay.
so that it'll run through the function and then get back. Will it stop when the value of that changes inside of the
Yeah,
function?
yeah.
Okay.
Yep. Yeah, next step only affects, if you don't hit a breakpoint or a watch point or an error,
Okay.
then it'll come back either beginning of the function or after the function returns. Yeah,
How does that work with recursion then? So like if you have,
very beautifully.
yeah?
Yeah.
Huh. Like if you have a function that calls that same function over and over again.
I think if you say next, it'll come back to you after it's finished the whole recursive tree.
Or,
Yeah, whereas if you say step, you'll be able to go through it. I'm 99% sure.
oh, cool.
Yeah. All right, question 2. How many bytes are allocated for the structure mystruct? So there's apparently a structure in here named mystruct, and we can't print mystruct because it's a type of structure. It's not a variable. But in C code, how would we find out how many bytes we need for a mystruct? Size of. Right, and oh, that was disappointing. Struct my struct without typos. Alright, so my struct is a structure that takes 32 bytes. I gave you the answer to question 2. What's the address of a variable named data?
Could you just do print and data?
Yeah, so print and data Looks like it's stored at location 60, 10, 60.
You
And when-
wanted
go ahead.
leaving zeros out of it, so it would be 60, 10, 6, or
Let's see what I said.
in the rules, like the very top.
So addresses should be entered in hex using lowercase letters beginning with 0x and suppressing leading zeros. So it'd be 0x, 60, 10, 60.
Oh, so if the zeros were after the 0x.
Yeah, because actually it's addressed 0x, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 60, 10, 60. So when we printed the address of data, it also told us not only that it's at 60, 10, 60, but that it is an array of 10 pointers to struct MyStructs. All right, this is because I put on the -G switch when I compile this. So even though we don't have access to the source code, we know something about data now. We know it's an array of size 10, and the elements of the array are pointers to MyStructs.
So how did you make it so that we can access the source code? You just compile it with a different flag, or?
I think I put these declarations in a file that I used the -G switch on, and then the main program I did not use the -G switch. I think. Took a few tries.
So because when I start for the quiz, you have to put in 60, 10, 60 for it to be the right answer.
Mhm.
How did you make be stored in 60, 10, 60?
I set it up in a way that it doesn't change, and then I just looked at where it was, and then I put the answer into the quiz. That also took a few tries. Well, if data is an array, we can look at the elements of it, right? So we can print data bracket 0. And now we got some more information. It's showing us the contents of the different fields of data bracket 0. So presumably these are the fields of a struct MyStruct. There's X, C1, C2, Y, F1, F, and Z. And we can start to deduce that C1 is a character, or maybe a string. Y, F1, F, and Z are integers, or maybe floats or doubles.
Can you figure out using this?
Yeah. Well, you can get closer to it. So what's the address of a variable named data, right? What's the address of data bracket 0? What's the address of data bracket 1? What's the address of data bracket 9? So you'll see a pattern here. And using that, you can come up with a formula for the address of data bracket I. This is the formula the compiler comes up with when it writes your code. And then it tells you the structure contains several fields within MyStruct. What field is stored first? Well, print the address of the different fields to figure this out. So for example, I can print the address of data bracket 0.
Dot.
Dot, yes, because it's an element of that. So dot F1, right, and it's stored at 60, 10, 6C. And it's also telling me it's 12 bytes past the beginning of data. So look at the addresses of the different fields and make yourself a memory map. Draw a picture that says, how is this structure organized in memory? What comes first, what comes next, what comes next? And then you can look at the size of, to figure out the size of each field, which will tell you, is this something that takes 4 bytes, is it something that takes 8, right? So print size of data bracket 0 dot F1, that takes 1 byte. So F1 is apparently a character. If it was a string, it would take 4 bytes or 8 bytes because it would be a pointer. So use that to help fill in your map. Right, now you know where each thing begins from the ampersand call, and you know how long it extends from the size of. So you can start to make something like this. And say, I don't know, this is X, and this is F1, and this is C. And this starts from location 0 to 3, and this is location 4, and this is location 5, and make a map. Now, you don't always have to do this for code that you're writing, unless your code's not working. And sometimes what you end up doing is even though you wrote the code, putting out on paper a memory map of how your structure is set up, or how an array of structures is set up, so that you can use that in debugging your program. If you're debugging program that you didn't write or that you don't have access to the source code for, you know, this is definitely one way to help figure out what's going on. And then the last part is, if you add up the size of each of these fields, it's going to come out to be smaller than 32. The struct mystruct takes 32 bytes, that's what size of tells us. But if you look at how many bytes you actually need to store each of those fields and add them up, it's less than 32. There's some empty space in a mystruct. And so this question is asking, where is the first location of empty space? So it's an exercise to play around with GDB, right? And like I say, this one, I strongly encourage you to work with friends on this. Mess around with it, just get in there and get your hands dirty, right? But I tell people, play with GDB, and it's like, well, what do I do with it? So here's some specific things you can do with it, right? Some things to try to figure out. And GDB is just super useful for like so many different things, including finding bugs or doing hacking or whatever. This was how I hacked Rogue the first time, was just running it through GDB and didn't have source code, but you can get a lot of information just from looking at code and executing it and looking at memory. No, does it say that? It should give you multiple attempts. I think I got a 0. Eh. Okay, so can I take it again? Yeah.
There's a setting for webcam required.
There's a what?
I saw a setting on the for the quiz. It said webcam required.
Oh, really?
Yeah.
There's so many things in Canvas that I don't know how to do, or that I don't know about. Webcam required, no, okay.
Just to make sure you're not cheating.
Yeah, yeah. Oh, right, yeah. Because they do that for like online courses sometimes.
Yep.
Yeah.
And then the lockdown browser sometimes.
So you get your sock puppet, like, I'm working. All right, so so that quiz isn't due until the 5th, but it's one I'd like you to work on, you know, presently. Quiz due is due tomorrow, but like I say, that's basic C syntax.
What's quiz 3?
And quiz 3 is also due the 5th, and I think that's the linked list quiz. So which of the following is true about memory and linked lists? A sentinel node and a linked list is. A linked list is. Thinking about linked lists as abstract data types, which of these would not be a piece of code that treats it as an abstract data type, and which of these would not be treating it as an abstract data type? So abstract data type, right, is basically saying, I don't care if you implement this with an array of struct nodes or with a linked list or with a whiteboard and a cell phone in the closet, right? It's basically saying this is your interface to the linked list, right? And the main program shouldn't have to know about how it's implemented. So if that's what's going on, then you're treating it as an abstract data type, which is what we want. But if your main program is checking the array to see if the valid flag is 1, then it's on the other side of the firewall. So that's breaking the idea of an abstract data type. All right, so tomorrow we will talk about PA3. I will post the assignment up probably late tonight, along with some sample executable code, and we'll talk about it tomorrow. It's going to be a program related to hashes and hashing, and I talked about this in the previous lecture, previous section, but I'll start it fresh tomorrow in here and talk about hash functions and things related to hashing. All right, I will see you tomorrow then.